Amanda. In this video, we will learn how to find the horizontal asymptotes of rational functions. We'll also look for any holes in the graph of the function, and we will use the vertical asymptotes and zeros and horizontal asymptotes and holes in the graph to explore the graphs of rational functions. Do you think you'll need to use factoring concepts? Probably. So let's just remember how to find vertical asymptotes and zeros. And the vertical asymptotes can be found by setting the factors of the denominator to 0. And the zeros can be found by setting the factors of the numerator to 0. Now, we're going to talk about the horizontal asymptotes. Number one, let's just call this h of x equals x squared minus 4 over x plus 3. And what I'm going to do is we've got this p of x and q of x, and that's the p of x is basically the numerator, and the q of x is the denominator. Just keep that in mind as we read. Okay, in this situation, it says if the degree of p, the numerator, is greater than the degree of q. The degree of p is greater than the degree of q. Okay, so this problem matches the first rule, or the first way to look at a horizontal asymptote, and that is when the degree of the numerator is greater than the degree of the denominator, then guess what? There is no HA, horizontal asymptote. Now let's look at this second situation where we have a function f of x equals x minus 3 over x squared minus 4. Now, of course, I know I'm going to be able to factor that denominator, but before I do that, let's look and see which one of these matches this situation. So we have the degree of the numerator is 1, and the degree of the denominator is 2. So, as you would guess, if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is the line y equals 0. So we're going to get a horizontal line at y equals 0. So that's a pretty easy, quick. HA is an equation of a line, y equals 0. That's our horizontal asymptote. Here's a fun one. This one's neat because I just want to look, and it takes care of this last situation here. And what we've got is if the degree of the numerator equals the degree of the denominator, x squared and x squared, the degree of the numerator equals the degree of the denominator, then the horizontal asymptote does exist. It's not y equals 0, but it is y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. Well, this is in the correct order from decreasing degree, starting with the highest degree. So the leading coefficient of this problem is, I'm just going to call it LC of the numerator is 2. And the LC of the denominator, you want to be careful because it's the coefficient of the degree of in front of the variable with the highest degree. It's in the highest degree. It's the leading coefficient. is a negative 1 because there's a negative x squared there. So that's a negative 1. So the horizontal asymptote in this situation is negative 2, or y equals negative 2. So we know that we would have a dashed horizontal line at y equals negative 2. That's our horizontal asymptote. Now let's come on over here, and this is a great problem to look at the vertical asymptotes as well. And let's do that. So I'm going to come over up here and look at this, and now I'm going to factor because I want to see the factors of the numerator and the factors of the denominator. I know greatest common factor. I can factor an x. X. And now I'm going to factor the denominator and say that x is 2x plus 1 over x plus 1, x minus 1. There we are. Okay, so we've got the factors of the denominator. So x plus 1, we're going to disregard this negative 1 because that's not really going to affect what we're doing here. The vertical asymptote, set the factors of the denominator to 0. We're going to get an x equals 1 and an x equals negative 1. Those are our vertical asymptotes. And then we'll do the zeros. We have to set each factor to 0 in the numerator. So I'm going to do the first factor, which is x equals 0. And so one of my zeros is 0. And then I'm going to set this factor to 0. 2x plus 1 equals 0. Uh-oh, what's happening here? 2x equals negative 1. X equals negative 1/2. So at negative 1/2, we are also going to see the curve cross the x-axis. So this was a good one. We've got the horizontal asymptote, y equals negative 2, vertical asymptotes, and the zeros. Let's take a quick look at holes in the graph. So you're running along the curve and all of a sudden there's a break or a hole in the graph. It is also a restriction on the denominator, but it's not a vertical asymptote. So let's just look at these two situations. And the first is I have a factored function, and obviously I can cancel the x plus 3 from the numerator and the denominator. Now, when you can cancel an expression in the denominator with the numerator, it's still a restriction. X cannot be negative 3. It would make the denominator 0, but it's not a vertical asymptote. Instead, it's a hole in the graph at x equals negative 3. It's a restriction on the denominator, but I canceled it. It's not a vertical asymptote. Let's look down here. Which one of these expressions in the denominator tells us that there's a vertical asymptote, and which one tells us that there's a hole in the graph? Well, here we have it. If you can cancel it, there is a hole at x equals 1, and there is a vertical asymptote at x equals negative 3, and that's the difference. If you can cancel it, there's a hole. If you can't, it remains a vertical asymptote. Problems to try. They're fun, they're easy, and they help reinforce the rules that we just learned about finding all the zeros in asymptotes.
Thanks for your help, puppy. And thanks for watching.